All right, here's a mind-bending thought. Everything you can see out there, every star, every planet, every single galaxy, all of it adds up to only 5% of the universe. So, what's the other 95%? Well, today, we're going full-on cosmic detective to hunt it down. And we're starting with the #1 suspect, dark matter.
Okay, so the first clue at our cosmic crime scene, it's all about speed. You look out across the universe and you see galaxies spinning way, way too fast. So fast, in fact, that the gravity from all the stars and gas we can actually see, well, it shouldn't be nearly enough to hold them together. They should be literally flying apart. But they're not. And that right there, that single observation, this massive cosmic anomaly, that's the central clue that kicked off a detective hunt that's been going on for almost 100 years.
To really wrap your head around this, just picture a merry-go-round, right? If you spin it way too fast, the horses on the outside are going to fly off. Simple physics. Well, galaxies are acting like that merry-go-round, spinning at an absolutely impossible speed, and yet the stars on the edge aren't going anywhere. It's like they're being held on by some kind of invisible ropes.
So who were the first detectives on this case? You've got astronomers, Fritz, Zwicky, and Vera Rubin. Way back in the 1930s, Zwicky was looking at the Coma Cluster and was just like, whoa, these galaxies are moving way too fast. But then, in the 1970s, Vera Rubin delivered the real smoking gun. Her work on the Andromeda Galaxy showed, without a doubt, that stars on the super far edges were orbiting just as fast as the ones near the center. And that just defied everything we thought we knew.
And this graph, this really gets to the heart of the whole mystery. See, physics predicts that as you get farther away from the center of a galaxy, the stars should slow down. That's what this dotted line shows. But that's not what happens. What we actually see is that they keep up their speed way out on the edges. That's this solid line. And that enormous gap between what we expect and what we see, that is the smoking gun. It's screaming that there's a huge amount of mass we just can't see. So, with all this overwhelming evidence piling up, scientists started to build a profile of our invisible culprit, the thing responsible for all this extra gravity.
And they gave it a name, dark matter. You can think of it as the invisible architect of the entire cosmos. It's like a gravitational scaffolding that allowed the very first galaxies to form, and it's what holds them together even today. I mean, let's be clear, without it, the universe as we know it, it just wouldn't exist. Period. So, what exactly do we know about this suspect? Well, the profile is bizarre, to say the least. For starters, it's completely invisible. It doesn't give off light, it doesn't absorb light, it doesn't reflect light. It doesn't interact with electromagnetism at all. The only reason we have any clue it's there is because we can feel its gravity. And that gravitational pull, it is immense.
And this is a really common mistake, so let's clear it up. The word dark here doesn't mean it's, black, like a piece of coal or a shadow. It actually means it's totally transparent. Light just passes right through it like it isn't even there. Okay, so this is where things get truly, truly humbling. You have to ask, just how much of this invisible stuff is actually out there? Because the answer, well, it completely flips our whole perspective of the cosmos on its head. Okay, get ready for this. This is the recipe for the entire universe. Everything we know, and I mean everything we've ever seen with any telescope, every star, every planet, you, me, this screen, all of it is less than 5% of what's out there. Just 5%. Our mystery suspect, dark matter, makes up about 27%. And the rest? Oh, that's an even weirder thing called dark energy.
Now, it's super important not to get these two mixed up. They sound similar, but they're total opposites. Think of it this way. Dark matter is like cosmic glue. It's an attractive force pulling galaxies together. Dark energy, on the other hand, is like the universe's gas pedal. It's a repulsive force that's pushing everything apart and making the universe expand faster and faster.
All right, so if it's not made of normal stuff like atoms, what in the world is it? Well, physicists have put together a lineup of the most likely suspects. For ages, the #1 suspect was something called a WIMP. That stands for weakly interacting massive particle. Basically, they're these hypothetical, really heavy particles that, just like the name says, barely interact with normal matter at all. Theorists have always loved this idea because WIMPs kind of pop up naturally in other theories that are trying to solve totally different big problems in physics.
Then you've got a competing idea, the axion. And what's cool about these is that they were actually thought up decades ago to solve a completely different physics puzzle. So if they also turned out to be dark matter, I mean, that would be like a perfect 2-for-1 deal for physicists. These guys are super, super lightweight. So
If they're the answer, the universe would have to be absolutely flooded with them.
And then there's the really exotic idea. What if dark matter isn't a new particle at all? What if it's made of ancient relics? We're talking tiny, primordial black holes, forged in the insane chaos right after the Big Bang, that have just been silently wandering through the cosmos ever since.
So with a lineup of suspects in hand, scientists have kicked off one of the most ambitious manhunts in human history. But here's the million-dollar question. How do you even begin to catch something that's totally invisible and can pass right through solid walls like a ghost?
Well, there are basically three main strategies. First, you go deep underground. I mean, they build these incredibly sensitive detectors in old mines like a kilometer down to shield them from all the cosmic noise. Then you just wait, hoping for that 1 in a trillion chance that a dark matter particle bumps into one of your atoms. The second strategy? If you can't find it, make it. At places like the Large Hadron Collider, they smash particles together at nearly the speed of light to see if any dark matter pops out. And third, you look up. You use telescopes to search for its fingerprints in space, carefully mapping how its massive gravity literally bends the light from distant galaxies.
But here's the thing. After decades of searching, after all these brilliant and massive experiments, our suspect is still at large. The case remains wide open. But the investigation itself has led us to a really profound and, honestly, a deeply unsettling truth about where we fit in the universe.
And this number says it all. This is the staggering reality of where we're at. We are, for all practical purposes, completely blind to 95% of the entire cosmos.
Think about that. The world of atoms, the stuff that makes up our reality, it's just a tiny bit of foam on the surface of a vast, dark, invisible ocean. The true nature of the universe, what it's really made of, is dominated by dark matter and dark energy.
And that leaves us with a final, really thought-provoking question. You see, the hunt for dark matter isn't just about finding some new particle. It's a quest to understand the actual, fundamental nature of reality. It's a huge reminder that, for all of our incredible progress, we've really only just begun to scratch the surface of what's out there. Thanks for joining this explainer.